Okay, good morning, good afternoon, good evening, whenever it is that you are watching this. Today we're going to be looking at a bit of a harder pulleys question, so I'm just going to share my screen so you can see it now. And it starts off by stating that two particles of mass 10 kilograms and m kilograms respectively are connected by a light and extensible string passing over a smooth peg, which I've sort of labelled here. And if it's 10 kilograms and m kilograms, so I'm just going to call that particle A and particle B. Both particles hang vertically like this, and one particle is held at rest, so it's not in movement at the moment. The particle is released, given that the acceleration of the particle is 6, find, and I want the mass, the tension, and the downward force on the peg. Okay, so looking at this system then, from what I can see, I'm going to get tension and a weight coming down for each one. So this weight is going to be mg and this is going to be 10g, and a tension coming off both. But I'm also going to get tension reciprocated by the pulley as it's trying to pull away from the system. So we need to think about what my mass could be. Now there's two scenarios. I can either have my mass being greater than 10 kilograms or have my mass being less than 10 kilograms. I will talk about why those are the two scenarios in a second. I just want to move this system across a little bit. So if my mass is greater than 10 kilograms, if we think about what's happening in the system, if this is larger than 10, the acceleration of 6 is going to be happening down, and on this side it's going to be happening up. So let's just think about this to start off with. I'm going to resolve my forces. So for shape A, I need to resolve vertically going up, and I would get my tension, take away my 10g, is going to be equal to my mass, which is 10, times the acceleration, which is 10 times 6. So my tension is going to be equal to 60 add 10g, and working that out, it's going to be 158 newtons. So my tension is 158 newtons. So moving on to trying to work out what my mass would be then. So looking at this right hand side for B, and I'm going to be resolving my force with downwards because that's the direction of movement. I'm going to get mg, so mg, take away my tension, which I've just worked out as 158, is going to be equal to 6 multiplied by m. So I can try and solve this. I can add 158 and take away 6m. So I'll get mg, take away 6m, equals 158. Factorizing for m gives me m lots of g minus 6 equals 158. So therefore my mass would be equal to 158 divided by, well, g minus 6 is 9.8, take away 6, which is 3.8. So 158 divided by 3.8 is going to be 41.57, blah, 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 blah. So it's going to be approximately 42 kilograms. And that would be for if my system had a mass of greater than 10. And obviously that would mean that my acceleration would be happening in the other direction. So I'm just going to make that smaller so it's a bit easier to read. Okay, and now I'm going to think about what would happen if my acceleration was in the other direction, which would mean that my mass would have to be less than 10. Well, that would mean that my acceleration would be happening downwards on this side, and it would be happening upwards over here. So again, I'm going to resolve for this side only because I have the weight already. So for A, sorry, resolving downwards this time. If I think about this, then I'm going to get my 10g, take away my tension, is going to be equal to, well, 6 times 10 again, which is 60. And now this time I'm going to have to add my tension and subtract 60. So 10g, take away 60 equals tension. So therefore my tension is going to be equal to 98, take away 60, which is 38. So my tension of a string this time is 38 newtons. So looking at resolving on the other side for B, if we resolve vertically, which would be good, I would get mg and tension. So tension take away mg, so 38 take away mg, and that's going to equal ma, well, 6a, because that's my, well, sorry, 6m. So 38 take away mg equals 6m. Now I need to add mg, so I get 38 equals 6m add mg. And then factorising 38 equals m lots of 6 add g. And then dividing by 6 add g, 38 over, well, 6 add 9.8 is going to be 15.8 equals m, which equals 38 divided by 15.8, 2.405, so it's going to be roughly 2.4 kg, and they would be my respective weights for m. So I've got my masses, and in the process I worked out my tension in my string. The downward force on the peg, well, if we're thinking about this peg, again, we'll have two different systems that could be in play. Well, on this peg, we're looking at the forces just happening around the peg. And the two forces which are acting are our tensions, and there's two of them, and they're both acting down. Each system, the downward force on the system where the mass is greater than 10, where it's 42, it would be equal to 2t, which would be 316 newtons. And in this system where the weight is less than 10, it'd be equal to 2t, but this time that would only be 76 newtons. And that would be how we answer a question involving a mass which is missing.